Hello, and in this video we're going to be looking at the third of those three differentiation rules, in this case the quotient rule. Now quotient means dividing, so unlike the product rule where we were timesing u by v, in this case we're looking at functions which are written as u over v, where again u and v are both functions of x that we can differentiate. Okay, so the formula is dy by dx equals v du by dx minus u dv by dx all over v squared, which I tend to write as y dash equals vu dash minus uv dash over v squared. And notice that unlike the product rule, it is not symmetrical. So it's important that we do the vu dash first and then take away the uv dash. So here we have four examples that I'm going to talk you through. We have y equals 7x over x plus 3, y equals e to the x over e to the x minus 2, y equals 3x minus 17 over x squared plus 8, and y equals tan x. So the other thing about the quotient rule compared with the product rule is that we don't have any choice over which is u and which is v. U is always the numerator and v is always the denominator. So we have u equals 7x, from which u dash just equals 7, and v equals x plus 3, from which v dash is equal to 1. And then substituting those into our formula, v u dash is x plus 3 times 7, which we normally write as 7 lots of x plus 3. uv dash is 7x times 1, which is 7x, but don't forget there's a minus sign between them. And then v squared is the square of x plus 3. And then we can just simplify at the top. So we've got 7x plus 21 minus 7x, which just leaves us with 21 on the top, and our x plus 3 squared on the bottom. Okay, for e to the x over e to the x minus 2, again, u is the numerator, so e to the x and v is our denominator, e to the x minus 2. U dash and v dash are both e to the x, because the only thing that isn't an e to the x is a negative 2, which just vanishes when you differentiate it. So we have v u dash, which is e to the x minus 2 times e to the x, and u v dash, which is e to the x times e to the x. So if we, and then we have v squared on the bottom, which is the square of e to the x minus 2. So expanding the brackets on the top, we get e to the x times e to the x. We could call that e to the 2x, but it's going to cancel with the other e to the x, e to the x. So all that's left on the numerator is minus 2e to the x, and we have our v squared on the denominator. Okay, now we have y equals 3x minus 17 over x squared plus 8. So u is 3x minus 17, and u dash is 3. V is x squared plus 8, and v dash equals 2x. So again, we start with our vu dash, which is 3 lots of x squared plus 8, and we take away our uv dash, which is 2x times 3x minus 17. We have our v squared on the bottom, the square of x squared plus 8. And on the numerator, if we expand the brackets, we have 3x squared plus 24 minus 6x squared plus 34x. And our 3x squared minus 6x squared will give us a minus 3x squared plus our 24 plus our 34x, and our v squared, x squared plus 8 all squared on the denominator. Now tan x, of course, as it's written, does not look like a fraction, but we know that we can rewrite it as sin x over cos x, both of which we've looked at how to differentiate in a previous video. So u is the numerator, that's sin x, and v is the denominator, cos x. Hence u dash is cos x and v dash is minus sin x. And then applying the formula, we have vu dash, which would be cos x times itself, cos squared x, minus uv dash, which is sin x times minus sin x. So our numerator becomes cos squared x minus sin squared x, which is of course the same as sin squared x plus cos squared x. On the denominator, we have our v squared, which is cos squared x. So simplifying that, sin squared x plus cos squared x is equal to 1. So that gives us 1 over cos squared x, which we usually write, because we've got our terms for reciprocal functions, as sec squared x. So if y equals tan x, then dy by dx equals sec squared x. So as I say, we've seen in the previous video how to differentiate sin x and cos x, and we've just used that then. And we've now looked at how to differentiate tan x. We could do something similar for cot x, sec x, and cosec x, because they can all be written as fractions as well. So y equals cot x can be rewritten as cos x over sin x. U is cos x, u dash is minus sin x. V is sin x, and v dash is cos x. So now our v u dash is minus sin squared x. Take away our uv dash, which is cos squared x, And if we factorize that, that's the same as saying minus 1 for the numerator. Our denominator is v squared, which is sine squared x. So dy by dx is minus 1 over sine squared x, which we rewrite as minus cosec squared x. And then sec x is the same as 1 over cos x. So u equals 1, and u dash is therefore 0. V equals cos x, and v dash is minus sine x. So our vu dash term is just 0. But we're going to take away uv dash. So we're taking away negative sine x, which is the same as plus sine x. And then v squared is cos squared x. So dy by dx is sine x over cos squared x. But we don't normally leave it like that. We rewrite it as sine x over cos x times 1 over cos x, which is the same as sine x over cos squared x. And then sine x over cos x is tan x, 1 over cos x is sec x, and then it's usually written in the order sec x tan x. So if y equals sec x, then dy by dx is equal to sec x tan x. And then for our final reciprocal trig function, y equals cosec x, we can rewrite that as 1 over sine x. Again, u equals 1, so u dash is 0, and v equals sine x, which means that v dash equals cos x. So applying the quotient rule, v u dash is again 0, but we're going to take away u v dash, so minus cos x on the numerator with a sine squared x on the denominator for our v squared. So dy by dx is minus cos x over sine squared x, but again we don't normally leave it like that. So we're going to split it up and write it as minus 1 over sine x times cos x over sine x, which gives us minus cosec x cot x. So in summary, here are 6 trig functions and their differentials. Sin x gives you cos x gives you minus sin x, tan x gives you sec squared x, cot x gives you minus cosec squared x, sec x gives you sec x tan x, and cosec x gives you minus cosec x cot x. So normally you just learn the circle of trig differentiation, which tells you that sine gives you cos and cos gives you minus sine, and the other 4 are quoted in the formula book, but it is nice to have them in your memory. So here are some facts not related to actual differentiation, but just language, if you like. So if you look at the table closely, you'll notice that if you differentiate something beginning with c, then the answer is negative. So when we differentiate cos, we get minus sin x. When we differentiate cot, we get minus cosec squared. And when we differentiate cosec, we get minus cosec cot. So the 3 that begin with a c all differentiate to something negative, and the ones that don't begin with a c end up with something positive. These rules, by the way, were found by a student in the past, not by me, so I'll just give her some credit for that. Secondly, where there's a tan, there's 2 secs. So what we mean by that, if you look at the row which says tan x f of x, then when you differentiate tan x, you get sec squared x. So where there's a tan, there are indeed 2 secs. But also, if we look at the row where we're differentiating sec x, we've got a sec x on the left and a sec x tan x on the right. So again, that row in total has 1 tan x and 2 sec x's. And then the third and final rule, very similar to the previous one, where there's a cot, there are 2 cosecs. So if you look at the row which has f of x equals cot x, then when we differentiate it, we get minus cosec squared x, minus of course because cot begins with a c, but where there's a cot, there are 2 cosecs. And similarly on the bottom row, where f of x equals cosec x, the differential is minus cosec x cot x, so again there's a cot and 2 cosecs. Thank you very much.